Hello. So my group members for project number 2 are Cosalinas, Myra Torres, and me, Alex Kwok. We chose to do the statics problem in which we are using MATLAB to evaluate the length and angles of the triangle. We will use these values to solve for the tensions acting on the cables supporting the weight of the object. Depending on the weight of the object, W, the length of the distance between the anchor points, and the length of one other side of the triangle, the values of tension we will find will differ. Our task is to design a script that can handle these inconsistencies and provide the correct and appropriate information for multiple test cases. In real-world engineering applications, being able to determine cable tensions at various angles and cable lengths is a crucial aspect in the designs of many projects. For example, suspension bridges. The laws that govern these tensional forces deal directly with trigonometric and equilibrium equations, involving sine and cosine to find the missing angles and cable length, with net forces equaling to 0. First thing we will look at is the Excel file involving our data sets. The first column of values is D, or the anchor points between the 2 points. Second values being W, the weight of the block being supported, and C being the length of LAB, the other side of the triangle. The first thing the script would do is checking for negative values, as seen here. If there are any negative values, the variable lock is made with the same dimensions of the variable data, which will place a 1 at any point of the matrix to know which positions are negative. The next line here will replace any value in the variable data with the absolute value in that position. The next check is for any value of LAB that is greater than D. The script will print out the values so the user will know which values to input that will be lower than the value of D. We will quickly put in those values for efficiency. So as you can see here, the program prints out the value of LAB and tells you that it is greater than D, which is here. So you will enter a new value. So after that, we will initialize the variables for the while loop here. So the while loop will continue to run if Q1 does not equal to 0 and Q3 equaling to yes. Q1 will refer to the next line here, which will ask the user to select the number of row or which number of row to be analyzed. As seen here, here are the values of which row the user will want to analyze. So if I click X, the program will send an error saying that I did not select a data set and the program will terminate. So I'll run the program again and put in the values. And then I will select the value of 4. The variables will then be set for input into the function. The variables D, W, and LAB will have Q1 in the first parentheses to know which row the values are in, and then the corresponding values for each column. So 1 being D, 2 being weight, and 3 being LAB. The length of LAC is found geometrically for the minimum value of D minus LAB, that being a line, with intervals of 0.1 to the maximum value, with LAC being the hypotenuse, thus using the Pythagorean theorem to solve for the maximum value. The for loop will then run here, which will send the information to the function with theta and phi being the angles between the sides and the tensions of the cables and the inputs that will be used. The outputs will have a parentheses A next to them to allow the length of the variables to change as the for loop continues until the last value of LAC. The function begins with the law of cosines to find the angles of the lengths between D, and then the linear algebra will be used to solve for the missing tensions. The variable coef has the coefficients of the missing tensions in each column, and the tensions will then be found with the matrix of weight and 0 divided by the variable coef. The tensions of each value is found by the corresponding value of variable tension. Back to the script. The program will continue to run and plot the values of each tension versus length AC in a subplot. The script will then print out the maximum values and corresponding length of LAC here. This will be the graph that will be shown. The program would then ask the user if they wish to analyze a different set of data. If yes, the script will clear the variables outputted by the function in order to keep it from having a matrix dimension error. So I will continue to run the script, typing yes, clicking a random set of data I want to analyze, and the subplots will be shown with the corresponding maximum tension and the corresponding length of LAC. I'll try again. Here's a different plot of data. Another one. So 13. Another plot of data. So this code can be used by an engineering student and professional to input their own set of data of weight, length of one triangle side, and the distance between the anchor points. Figure out how much tension is there for both cable lengths. Some limitations are that the script doesn't check for missing values in the Excel file and asks the user to input for an appropriate value. It also doesn't show a maximum value of tension as it shows infinity, and the comparisons between the cables are quite difficult in the subplot. The script also keeps showing a warning for the function with matrix is singular to working precision, and I'm not sure what that is for, but that's all.